Welcome to a lesson with Dr. Powell. Let's take a look at some limits that we can compute where we have x and y heading to a point, not just x, not just y, but a coordinate pair, x, y, getting close to something. Let's do 0, 0. And let's start with x squared minus y squared over x minus y. Now, you might actually expect to get from this something interesting. You see, this is kind of like taking the graph of x squared, but like picking two different points on it, or in the input like x and you could say x plus h, but I'm just going to do x and if we think of x and let's do x1 and x2. You can almost think of this as being x1 and x2 and x1 and x2, and then see what this is doing. This is like your run, and that's like your rise. So really, it's computing the slope as xy. So as both of these guys head toward the same value. So here, 0, 0. So we can expect, well, the slope actually, as both of these guys head towards 0, 0, that would be like looking at the slope of the tangent line right there. We can expect then that perhaps this limit would be 0. Let's actually go ahead and see if that's true. So going for it, we have x squared minus y squared all over x minus y. And let's factor this top. So we get a limit. I'll just write limit, but knowing what it is. So we get x minus y, x plus y is a difference of two squares over x minus y, and those in the limit, x and y are going to 0. So now we can just plug in. Notice before we couldn't just plug in because we had this would be undefined if we plugged in. So in the limit process, we can do the same thing as we did before with limits, factor, do some algebra, do some cancellations, then plug in. And we end up getting 0 plus 0 at this point, which is 0, just as expected. Okay, now let's try another one and see if you can guess what it is as we go along. What if we did the limit as xy approaches 0, 0 of x squared minus y squared, or not, let's do 1. That's what I meant to say. As xy approaches goes to 1, 1 of x squared over y squared over x minus y. You'd expect maybe this is like the derivative or the slope of a parabola y equals x squared right at the point 1. So that slope right there, the slope of that tangent, which we could expect, the derivative of x squared is 2x. So plugging in 1, we should expect to get out 2. Let's see if that's what we get in our limit. Okay, well, proceeding the same way, we can really use the same step. X minus y. And notice we can't just plug in 1, 1 because it makes the denominator 0 right now. But here these cancel, but then on plugging in 1, 1, we do get 2. So it's just another way of maybe limit computing a derivative, perhaps using two different variables. This is just one example. We'll look at another example in the next video. Thanks for watching.